there are special types of limits that we did not consider, and those are limits when our variable approaches to infinity. Well, they could be taken pretty much the same way in some exercises, like in exercise number 27, for example, when you have function x cubed and etc., and you want to find its limit when x approaches to infinity. So what we're going to do, it's section 1.5. I will return back to chapter 2 later. Today I'd like to look at some of chapter 1.5 because I almost left it out by accident, and that's why I saw actually last time when I was browsing through it, and I noticed, so I said to myself, I need to definitely go back, and that's why we're back. So if x will approach to infinity, what does that mean? It means that x is very big number. How big is it? Is it a billion? Is it a trillion? It's very big. It's bigger. It's going to infinity. Well, it turns out then this thing is also going to be big, because if x goes to infinity, then the cube is going to infinity. And turns out they say it's a dominating term. So we just care about the largest power, which is 3, because power of 2 is smaller. I say, how do you care about third power? Well, because if you, let's say, take some number like 100 and cube it, and then put minus 100 squared 4 times and minus 4, just plug it in 100 to show you that all we care about is the biggest power. Then you're going to have 1 with 6 zeros in the first place, minus 4, and then 1 with just 4 zeros in the next place. And notice that 1 with 4 zeros is just a 4,000, but this is a million. So whatever is after the million, this 1,000 or 40,000 is not really much compared to the million. So that's what dominated, and that's why we'll look at the sign of this value, which is a positive, and the result is infinity. Or actually, sometimes people put a plus sign with infinity, say it's a plus infinity, because in the next portion of the exercise, so they wonder, is that a negative infinity or positive infinity? So if you tried to find exact same limit, so I copy this cube and 4x squared and minus 4, but now if we send x to negative infinity, well, the result will be now with a negative sign, so it'll be minus infinity. Again, the reason is that all I care about is dominating power, the largest power, because the rest is not really making much difference, as we just saw here. And that's why, since power is 3, and we are dealing with some negative number, negative big number, when x approaches to negative infinity, it's like negative million, negative 10 million, 100 million, it's negative. So the negative sign is still going to stay when you cube it, when you raise to the power of negative. So it looks like in the case of infinities, just get infinity, but not always. And the problems like 31 exercise, we're going to need to do a special procedure with this function. The procedure is dividing by the same power, because notice in number 31, we have x squared on the top and x squared on the bottom. So what people do to find a limit when x approaches to infinity, and that's only for the cases when x approaches to infinity. Other limits, we look for the other ways. So we take this fraction, and then we divide each piece of this fraction by the same exact number by that largest power of x that I saw, and that's x squared. So if I put the largest power of x, or x squared, underneath each piece here, everywhere, actually, then these x squared terms will nicely disappear, and that will be the point of why doing that. So if you take a look at the remaining part, I just need to write this. It takes a while to put all that down. So we're going to have just number 1 here, minus 2 over x, because x squared and x cancel, and finally plus 3 over x squared. And analogously with denominator, this will be 2 plus 5 over x, and then finally plus 1 over x squared. And these pieces, turns out, will all disappear. For example, 5 over x, when x is big, is going to be like 5 divided by something very big. Why x is big? Well, because they told us that x approaches to infinity. I say maybe negative infinity. It doesn't matter. If you divide by negative big, it's still going to be pretty much 0, small, or disappear. The idea of all that process is to make sure that these go away. So whenever x is in your denominator, and of course it approaches to infinity, that's the key part, well, then these fractions will all go away, and all I left with will be 2 on the bottom and 1 on the top. So this is the answer, 1/2. And it doesn't matter if you have x approaching to plus infinity or to a negative infinity, because x is not participating. It just leaves you with whatever is left, 1 on the top and 2 on the bottom. And I want to make a key observation here. The fact that we have same powers on the top and the bottom of this fraction, I don't have to create so much mess to do this exercise. I could just say 1 is with x squared on the top, 2 is with x squared on the bottom, so my limit is 1/2. Analogously, for next exercise, I could do the same exact thing. I can see that we have cubes here, right? So I can say the limit will be -3 on the top, coefficient, and +2 on the bottom. So it's -3 over 2. And that's it. So you just look at the quotient of so-called leading coefficients if powers are the same. Because in the others, here powers are not the same, so you need to do something else. But if powers are the same, then it's pretty straightforward to just divide those so-called leading coefficients and get yourself the answer. So how about if I try number 33 exercise here? What the limit is going to be in this case? And the answer is that the denominator is going to dominate. In exercise number 33, just like in the problems that we considered previous, it's going to be something like analog of something fixed over big. Let me write this down so we'll better see this. So if I take a limit of 2x plus 1, which is divided by something with square, 3x squared, and also plus 2x and minus 7. Then what I can do is consider limit when x approaches to infinity. And if it's negative infinity, well, it may differ by the minus sign, but usually not really. So, but we'll see. So I can do analogous procedure to what I had in a previous exercise. I can consider so-called degrees. Remember, I divided everything by like x squared, and on the top and on the bottom. So same here. I see degree, or the largest power, on the top is 1, and the largest power on the bottom is 2, right? So what I'm going to do is select that power of 1 and divide everything by it. In other words, fraction does not change if I multiply on the top and the bottom by 1 over x. So if I take 3x plus 1, and that same thing here. It takes a while to write it. It's tedious. The idea is take the lower power from the top or bottom or first power of x, and just divide everything by it, and then see what you're going to end up with. So after you simplify, just like in the previous example, you're going to get 3 on the top and 1 over x on the bottom. And we already know that 1 over x we don't care for, it's going to disappear. Now we have 3x here on the bottom, and then plus 2 and minus 7 over x left over. So when x goes to infinity, then these little guys will go away. 1 over x and 7 over x. They approach to 0 because, again, that's a fixed number divided by big. And the big, well, dominates and goes to infinity. So you divide 1 by infinity, which is something small. Now, same thing is going to happen here now. Because what you do is you divide 3 by big. See? This is big in denominator, and 3 is in numerator, so this whole thing is small. So the answer is 0. Notice that whenever you have x in denominator, then your fraction disappears. Same here. We have x in denominator, fraction disappears at 0. And that's actually given us a rule, so you don't have to every time go through it. It says whenever you have, like in 33, for example, your denominator that dominates, then the limit will be 0. And again, it doesn't matter if x goes to plus or minus infinity, it's 0, right? So I don't really care about the sign of infinities in this case. The only place where we care about this is exercises of that type. So it turns out there is a third possibility here, because we considering our so-called degrees of numerator as well as degrees or largest powers of denominator. So we're looking at these powers and we say, if powers are the same, well, we just divide those leading coefficients. What I'm talking about, again, let's just recall, like exercise we just did, 31. So we saw, it's x squared here, x squared on the bottom, and 31. So I just divided 1 by 2, and that's how I got 1/2. If degrees were the same, both squares. Or if denominator has bigger degree, or we say it's dominating this denominator, like in the couple of problems we just saw after that. So this is like exercise number where we had denominator like 34, for example. I see x squared here, but the biggest power here is x cubed. So what dominates? Denominator. That's it. You divide x squared by x cubed, or like 1 over x, which is 0. So whenever denominator dominates, it's always 0. Always. Always means always, right? So never anything else. But the power of denominator is bigger. Now one can say, Alex, what about number 35? If power of numerator is bigger, you see the difference? In 35, numerator dominates. Well, then what I can do is actually divide. And I think I better maybe divide number 36. Because 35 is a kind of nasty exercise. But I'll do it anyways. But let me start with something better rather than with nasty, right? Exercise number 33. Oh, I didn't write it correctly. I read 34. So you said I miswrote. I wrote instead of 2x plus 1, I put 3x plus 1. Okay. So what you can do is, let me see, you just fix that instead of 3, you put 2, right? Thank you. Thank you for noticing. Well, it doesn't matter. You divide 3 by big or 2 by big or any number divided by big, it's small. See, the key idea is as long as big is in denominator, that's it, it's 0. When x approaches to infinity, right? So it's like 2 over infinity goes to 0. See, we don't want to put equal sign because it's like limits, and that's why I kind of being careful about it. But thank you for your notice, and I missed that. And that's good that we're going over this, because the key idea, we don't really care for numbers. We care for powers of x, whichever one dominates on the top or on the bottom. So now we found the problem 36. And turns out for exercise 36, I could treat this as minus 2x cubed plus 1, which is divided by x plus 1. So now what can I do to find a limit? And the answer is, all I can do is divide that x plus 1 into negative 2x cubed and plus 1. And the way we divide, we use this long division process. See, I told you it's tedious. But I think it's good that we look at it once and then maybe we'll see it once again. My goal is not to concentrate on these kinds of exercises simply because they're nasty. But it's good that you see they're not really that bad, they're doable. And the way to do is to actually long divide. So you multiply by negative 2x squared, both nx and 1y negative 2x squared, because my goal was to divide negative 2x cubed by x. And then it'll be minus 2x squared next to it. And then I have to subtract. Remember how division goes? We take these first terms cancel, then we subtract, so this sign changes because 2 minuses, we subtract in negative. And then we copy whatever's left, 2x squared, and that plus 1 will be with us for a while. And then do this again, divide this again. So put plus 2x. You see? So you got a 2x times x plus 1. So you distribute this carefully. And then see what else is coming out. So it's 2x squared and plus 2x. So now we subtract these, the sign changes, so it'll be minus 2x, right? Because we subtract, we'll always change sign. And still have plus 1. And a good thing, it's a last step. So I go with a negative 2. And then it's minus 2x. And then negative 2 times 1 is negative 2. So when subtracted, these terms cancel, that sign changes, we get a 3. And then I'm going to be able to write our quotient. So what do you do? I'm dividing here. I produced a quotient, negative 2x squared and 2x and minus 2. And then whatever remains, 3 over x plus 1. So I just was able to divide. So the point of doing this is to help us visualize how to find the limit. Remember, they asked us for a limit. So limit of that is same as limit of that. Notice when x approaches to infinity, this denominator is irrelevant because that disappears, right? Like 3 over big, that favorite story. And now what dominates gives me the sign, the actual answer. And it looks like dominating term is 2x squared. So when x goes to infinity, then this 2x squared also goes to infinity, but it's negative 2. So it's a negative infinity. Of course, you don't need to solve it that lengthy, but the idea behind that solution is long division. And I actually took pains to do the long division because that's what we're going to need for graphing. So eventually, in the chapter after next, when we see where we use these derivatives, and that's graphing story to graph those functions, and that's where we're going to actually do this long division procedures. I'm not gonna really ask you now for worrying about this because I think it's very tedious. And I also think that you should see it once and then you see it again, and then eventually again, when you see it third, fourth time, you will start to like it better. And that's the idea. So they have a group of exercises here with this limits at infinity. And maybe I'll do one more and then ask you to do one, because it's just one little group of problems here. But I believe that this is something that's worse for the future. So I wasn't really doing them when we had limits on purpose, because now I can spend, I think, more time on them. Because this really is a calculus, and that's worse to slow down and to maybe see more exercises. In fact, it looks like I'm doing all of them today, except for the first ones, right? Maybe one of those first ones I'll ask you to try. So I'll try now the one that I skipped here, and that'd be 35. I guess I'll do it here, so it needs some room. So here we have to take a limit of fraction with 3x squared minus 6x and plus 2 divided by 2x minus 9. So I don't want to do the long division here because there'll be fractional coefficients. I mean, I can do this, but I don't think anybody is going to like it. The reason is if you start to divide, I will start. I love long division, but I don't want to really make you feel uncomfortable. That's why I'll show you why I don't want to do it. So here's my division. Now I divide first terms. I divide in 3x squared by 2x. So how many times I need to take 2x to produce 3x? And turns out it has to be 3/2 x. You see what happens? Then I have to multiply these guys and I will get 3x squared, but the next term will be 9 times 3 is 27/2. And see, I'm going to end up with all this fractional stuff, and now it'd be a little bit messy. So I don't think that people prefer to do division like that, but notice that this 3/2 x is going to be already quotient plus some more stuff, right? So it turns out that we're going to end up with taking a limit of 3/2 times x. I need to write it a little bit better. It's not enough room here. Maybe I'll put here. So the limit of 3/2 x plus some more stuff. But we don't really care for more stuff because when x approaches to infinity, all we care about is dominating term, the largest power. So this will be infinity. You see the idea that all we care about is just the first term. And that's, I think this exercise is a little bit too much because they should have put a nicer numbers. They could have put not 3x squared, but say 4x squared, and we would be able to divide and everything be nice. But I don't know, they just put it like that. So anyways, the point of story that the limit is infinity. And again, you could see it right away because the power of numerator dominates. So my message is when you have bigger denominator, it's 0. Bigger numerator, it's infinity. Numerator dominates, so it goes to infinity. Denominator dominates, so divided by big, it's small, so it's 0. I guess that's the key message of this little group of exercises. So let me try one more for you here. Let's say exercise number 28. So what do you think limit in 28 is going to be? Well, when you look at this 4-term polynomial, you will say to yourself, what's the largest power here? 2 or 3? Well, looks like we have 3x to the power of 3. So when x approaches to infinity, then this term goes to infinity, right? So it looks like all of these exercises have to do with limit equal to infinity. If I ask you for exercise 29 for a quiz, then to be clear of what we deal with, I would just why x cube approaches to infinity? When x approaches to infinity, because x cube is always bigger. So let's say if x is 10, x cube is 1,000. See, it goes to infinity even faster. But x goes to infinity, it's not just 10. To infinity, it could be some big, right? So if x is that, then what's x cubed? Can you imagine how many zeros there be? 2, 4, 5. So it'll be 5 times 3, 15 zeros. So idea is whenever you have x that is big, then the power of x is even bigger. So it's bigger, right? So if you take number that approaches to infinity and you start to raise it to various powers, like 2 or 3 or whatever, the results are also approaching to infinity. That's the idea. So whenever you have the x approaching to infinity, right away, if you don't have any denominators, the result is infinity. Well, that's the message. It's just like plugging numbers in. That's how we started to think of limits. We're plugging numbers in, basically, right? So you plug infinity in there. So what do you get? It's just big number, infinity. So anyways, returning back to the question that I'm asking you, I wanted to help you out a little bit. The point here is to make it look better, simplify it. So instead of having this with parentheses distribute, you're gonna get something like minus 2x squared, that's the largest term, product of the ones inside. Then you have plus 1 times x. Then also negative 2 times 5 is negative 10x. And finally, numbers 1 and 5 will give you 5. So it looks like this is what you need to find, a limit when x approaches to infinity. So what's the limit when x approaches to infinity? I say, Alex, if that's infinity, how can I put this symbol? Just write word infinity, that you can just put that. But I think that's simple, right? So the message is always simplify expressions when you, before you start dealing with them, because that way life is easier, right? Simpler, that's why we're simplifying. So that's a little quiz for today. Please give it a little thought and don't hurry. What is the answer? And I'm sure you already know what the answer is, right?